Alright, hi guys, I'm Zach. I'm going to be showing you an alternate method or algorithm for multiplication. So typically you guys have all learned the standard algorithm, which I'll show you now using the numbers 26 and 73. So normally we line them up 26, 7, 3 to have our ones digits lined up and our tens digits lined up. So start off 3 times 6 is 18, 8 carry the 1, 3 times 2 is 6, plus the 1 is 7. Have our placeholder is 0 because now we're working in the tens digit. So like normally 7 times 6 is 42, but because it's 70, it's actually 420. So we have our 20, and then we carry our 4 for the 400. Now 7 times 2 is 14, plus 4 is 18. So we have 8 plus 0 is 8, 7 plus 2 is 9, 8, and 1. So yeah, so this is the answer 1898 for the standard algorithm. I'll write that up here, 898, because we're going to get rid of this one real quick while I show you the area method. And area method, when you think of math and you think of area, there's like area and perimeter, and that's basically what this method is. It is using a visual representation of area of a rectangle to give you the big picture of how to do this multiplication problem. So if students have done area problems in the past and can relate it to it, it might help them doing the new multiplication problems that are a lot bigger. So we start off by making a nice large rectangle. And so our numbers are 26 and 73, so we're going to put 73 along the larger side and 26 over here on the smaller side. So basically how this will work is we're going to break down each number into its tens and ones digits. So this is 70 plus 3, and 26 becomes 20 plus 6. So now that we have them split up, we're going to break down the sides, the other sides that line up. So we have 6 and 20. Oops, that's not a great 0. 6 and 20. And then we have 3 and 70. And so then we extend these lines to create an area model. So each rectangle represents a multiplication problem, which is area, how we find area normally. So like this box is 6 and 3, this box is the 6 and the 70, the 20 and the 3, and then the 70 and 20. And it like shows like how much bigger the numbers are. So like 6 and 3 is going to create a small area, but the 70 and 20 is going to create a large area. And so it helps the students to just recognize that stuff and make those connections in their mind for when they go over there that it's going to be a large number. So we start off our one digits, 3 and 6 gives us 18. Now 6 and 70 is 420. 3 and 20 is 60. And 20 and 70 is 1,400. So now we come up back and we add up all the rectangles to get the area of the full rectangle. So we start off with 1,400. Then we take our 60 and our 420. Now we have our 18, and we add them all up. So this is just the 8. Here we have 2 plus 6 is 8, plus 1 is 9. 4 plus 4 is 8, and 1, which, as you can see, is the same as what we got from the original problem up here, 1898. So a lot of the stuff is still the same. So in the original problem, we had the 26 and 73, and we multiplied the 6 by the 3, and then the 6 by the 7. And then we took the 20 and multiplied it by each of them, 20 times 3 and 20 times 7. And then we added up the numbers at the end. So this is basically the same. We're multiplying 3 times 20, 3 times 6, and then 70 times 6 and 70 times 20. Get all those numbers and add them up. So more or less it's the same, and it just provides a visual representation for the students to realize what they're doing, and it makes sense to them because they've done area models before. And then when you come over here and you're like, oh, the 3 is still being multiplied by the 6 and the 20, they can visualize it and see how it works. So it's not the same as the normal standard algorithm, and it might take more space on the paper and more time, but as long as it's drawn the bridge between getting us from where we are to where we want the students to be, where they can do the quicker, more efficient standard algorithm, that's what's important, and that's what we need to do to get the students there. So yeah, I just hope this was helpful, and thanks for stopping by.